All right, today we're looking at something that could totally flip the script on how AI handles language. It's a wild idea from DeepSeek that asks a simple question. What if, to process a huge amount of text, an AI didn't have to read it, but could just see it instead?
So, let's just start with this question. What do you think is the single biggest bottleneck for modern AI? I mean, what's holding it back? Is it raw computing power, access to data, maybe the crazy complexity of the algorithms?
Well, the answer is probably not what you're thinking. Believe it or not, the biggest hurdle for these massive AI models might be the one thing they're best at: reading. Yep, you heard that right. Their greatest strength is, in a very real way, their biggest weakness. And this gets us right to the heart of what the community calls the long text problem. You see, when you ask an AI to process a really long document, I'm talking a dense research paper, a complicated legal contract, even just the entire history of a long chat, it starts to choke. And it all boils down to one tiny, fundamental concept.
And that concept is the token. Now, a token is basically the smallest unit of data for a language model. Just think of them as little pieces of words. And here's the kicker: the more text you've got, the more tokens the AI has to deal with. It's that simple.
So the way we do it now is, well, it's kind of brutal. You feed a long document to the AI. A tokenizer comes in and just smashes the text into thousands of these tiny token pieces. Then, the poor LLM has to slog through this incredibly long one-by-one sequence of tokens. And the result? It's slow, it's super expensive, and it really limits how much stuff the AI can keep in its working memory or its context window. Okay, but what if we've been thinking about this all wrong? The folks at DeepSeek came up with a really brilliant, out-of-the-box idea. They asked, what if we stop forcing the AI to read word by word and instead just let it see the whole thing at once?
You know that old saying, a picture is worth 1,000 words? Well, that's not just a cute phrase here. It's the entire foundation of this research. The idea is to literally turn a block of text into a picture and then have an AI that's good at seeing take a look. The official name for this is C-text optical compression, and what it does is pretty revolutionary. It takes that long, messy string of text tokens and converts it all into a single, super compact image. And I mean, this isn't just a little tweak to the process, it's a whole new way of thinking. And this just lays it all out so clearly. Look at the old way on the left. Text turns into this long, inefficient mess of thousands of tokens. Now, look at the new way on the right. Text becomes an image, and that image becomes a neat, super efficient set of just a few hundred visual tokens. The difference in efficiency is just, it's absolutely massive.
Okay, so the big question is, how on earth does this actually work, right? How do you get an AI to see text and pull out the meaning so efficiently? Let's dive into the architecture.
The real magic, the secret sauce, is all in how they design their image encoder. See, a lot of older models use multiple encoders working in parallel, which sounds good, but it's actually kind of clunky and inefficient. DeepSeek decided to use a much smarter two-stage process that happens one step after the other.
And the way they explain it is perfect. So first, you have an encoder that's a bit like the one in SAM, that's the segment anything model. Think of this first step as a magnifying glass. It zooms in and scans the text image really closely, picking up all the fine-grained details. That's what creates the first batch of vision tokens. Then, for step 2, a clip encoder comes in. Its job is to take all those little details and step back to see the whole painting, the big picture. It puts everything into context and basically acts as the translator for the main LLM.
In that specific order, details first, then the big picture, that's the whole ballgame. It's the key innovation. This sequential process is what lets the model grab all the rich, important info while spitting out just a tiny fraction of the tokens you'd get from those older parallel models.
All right, so it's a super clever idea on paper, but the real question is, does it actually work? Let's look at the numbers and see how it performed when they really put it to the test.
First, just look at this number, 10.5. So what are we talking about here?
That's a 10.5x compression ratio. I mean, that is staggering. They took a piece of text that would normally be about 670 text tokens and squished it down to just 64 visual tokens. Think about that. That's a massive, massive drop in the amount of data the AI has to chew through. But here's the thing. Massive compression doesn't mean anything if you lose all the important information, right? So what about accuracy? Well, even with that insane compression, they were still able to reconstruct the original text with almost 97% precision. That's incredible.
And what I really love is this trade-off you can make. It's like having a dial. So if you're working on something where you need absolute maximum precision, you can ease up a little on the compression. For example, using 100 visual tokens instead of 64 gets you an even better precision score of over 98.5%. It's just so flexible.
This chart really drives the point home. You've got other state-of-the-art models that, yes, they have high accuracy, but look at how many tokens they need to get there. We're talking in the thousands. DeepSeek-OCR, it gets that same high-level performance using tokens in the hundreds. That's not just a step up, that's an order of magnitude leap in efficiency.
So, let's zoom out and think about the big picture here. Because this isn't just a cool trick for reading documents faster. No, the implications for the future of AI are actually pretty profound.
I think the real game changer here is giving AI agents a kind of efficient, long-term memory. You know, one of the biggest problems we have right now is getting AI to remember stuff from long conversations or from way back in the past. It just can't hold on to that much information. Well, this could be the key to solving that.
And the researchers use this absolutely perfect analogy: human memory. I mean, think about it. You don't remember every single detail from 5 years ago, right? Those old memories get kind of fuzzy, a bit blurry, but what you did this morning, that's crystal clear. This technology could let AI memory work in the exact same way.
So, picture this. An AI agent stores its most recent conversations as high-resolution images. Every detail is there. But as time passes, those images get automatically downsized, becoming lower resolution. The AI basically forgets the nitty-gritty details, but it holds on to the gist of what happened. It's a way to mimic human forgetting, freeing up resources while keeping the important stuff. This could literally be the solution for giving AI agents a near-infinite, but still totally efficient, memory.
And that just leaves us with this one mind-bending question. For so long, we all just assumed that the way forward for AI and language was, well, more language, more text. But this paper throws a wrench in that. It makes you wonder, is the future of language processing actually visual? What if the best way for a machine to understand us isn't to read our words, but to simply see them?